Good afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about a radio receiver. Radio receiver, it is nothing but an electronic circuit that picks up a desired radio frequency signal and requires the baseband signal from it. It not only demodulates the incoming message signal, but it is also required to perform some other system functions such as carrier frequency tuning, filtering and the amplification. Carrier frequency tuning is nothing but to select a desired signal. Filtering is nothing but to separate the desired signal from the other modulated signals. Amplification is nothing but to compensate the loss of signals during the transmission. The various radio receivers parameters are that is, we'll call it as a characteristics of a radio receiver: sensitivity, selectivity and the fidelity, where these characteristics judge the performance of a radio receiver. There are several parameters which is commonly used to evaluate the ability of a receiver to successfully demodulate the signal. The first one is sensitivity. Sensitivity is nothing but the ability of a receiver to detect the weakest possible signal and amplify them is known as a sensitivity, where it is the minimum RF signal level that can be detected at the input to the receiver and still it produces a usable demodulated information signal. The sensitivity of a receiver is dependent on the RF and the IF amplifier stages. By increasing the gains of these stages, it is possible to increase the sensitivity of the receiver. The best way to improve the sensitivity of the receiver is to reduce the noise level. This is the sensitivity curve for the good receiver. The next one is a selectivity. It is a receiver parameter that is used to measure the ability of a receiver to select a signal of a desired frequency while rejecting the all others. The selectivity decides the adjacent channel rejection of a receiver. Higher the selectivity is the adjacent channel's rejection and less is the adjacent channel interference. Higher the Q factor of the tuned circuit used in the RF amplifier, where the selectivity will be better. Q factor, it is nothing but Q factor equal to Fc by bandwidth, where Fc is the carrier frequency or the center frequency. Better selectivity means that the receiver has greater capability to reject the undesired signal. The next one is a fidelity. It is the ability of the receiver to reproduce all the range of modulating signal at the output of a receiver, an exact replica of the original information. It basically depends on the frequency response of the AF amplifier. If any component is missed or attenuated considerably, fidelity suffers and the reproduced signal is distorted. This is the fidelity curve, where minimum attenuation and the frequency response of a AF amplifier is shown. This feature is mainly decided by the bandwidth of the audio amplifier, which amplifies the baseband signal. There are various classification of radio receivers: coherent and the non-coherent receivers. In coherent this non-coherent or asynchronous receiver, where no frequencies are generated or the frequencies are used for demodulation and completely independent from the transmitter's carrier frequency. Whereas this detection is also called as envelope detection, because the information is required from the received waveform by detecting the various signals. Where the types of non-coherent radio receivers are based on the principle of operation. Only two types of receivers which we have real and commercial significance. They are a TRF, will we call it as a tuned radio frequency receiver, and a super heterodyne receivers, where TRF is the oldest and the simplest designed radio receiver, where super heterodyne is the most popular and widely used radio receiver due to many of its advantages over the TRF receiver. The assessment is nothing but we have to mention the functions of the receiver. where functions is nothing but a characteristics of the receiver, as we have seen fidelity, sensitivity, selectivity. Other than that, we'll be having a noise figure and the image frequency rejection ratio. Then we have to write about the Q factor of the tuned circuit. Then why non-coherent detection is called as an envelope detection. Thank you.